In this video, I'll be going over a misconception I see in Math 260 pretty early on. So, let's say we've got a conditional statement whose logical form looks something pretty simple. P implies Q. Okay, so a lot of the time, students will think that the inverse, the contrapositive, and the converse are all equivalent to P implies Q. However, that's not true. Only the contrapositive is. So the inverse of this is not P implies not Q. The converse of this is Q implies P, and the contrapositive is not Q implies not P. So out of all these, only the contrapositive is equivalent to the original statement. So I'll show you why using a truth table. So let's set that up. P is Q. P implies Q. Not P implies not Q. Q implies P. Finally, not Q, not P. So here's the inverse. Here's the converse. Here is the contrapositive. So let me divide all this up, right? 1, 2, 3. Extend these a little bit. So true, true, false, false, true, false, true, false. That's just setting up our truth table. So if we're looking at P implies Q, we've got true implies true. That's true. True implies false is false. False implies true is true, and false implies false is true. So I'm sure you guys have already done a bunch of truth tables, so you should be able to fill all this stuff in. So now we're going to look at the inverse. Not P implies not Q. Oh, well. So that's going to be false implies false, which is true. False implies true, which is true. True implies false, which is false. And then true implies true, which is true. So notice how the inverse here doesn't have the same truth table as the original P implies Q. So that's why the inverse isn't equivalent to the original statement. And we'll find it's the same thing for the converse as well. So if we're looking at this, we're going to look at Q implies P. So true implies true is true. False implies true is true. True implies false is false. False implies false is true. And once again, we'll see that this doesn't have the same truth table as the original statement. Notice right here where on the second line it's true, but in the original it's false. Same thing goes here for the inverse. So for the contrapositive though, this will wind up being the same truth table. So we'll have not Q implies not P, so false implies false, which is true. True implies false, which is false. False implies true is true, and finally true implies true is true. So now notice this whole truth table is equivalent to the original statement. So we can see now that the contrapositive is the only version of it that is true. So I think that'll do it for this video.